Okay, so I think we left enough time to people to join and to go through WOVA and other links. I will be checking at the break the workshop page to see if people have problem to connect, and if so, we'll try to manage. So I'm very pleased to welcome you to this workshop. I wanted to go through the number first. So we had 195 participants registered. So it seems that not everybody made it yet. So we will see when the first session starts. We'll see if we have a bit more people. And the interesting part is we have around 50 institutes that are represented. So it will be quite interesting to have discussion around few subjects with different institutes around accelerators. So again, thanks for joining. I hope it will be an interesting workshop for you. And we wanted to explain a bit why we decided to do a workshop, because at the end of last year, we learned that CentOS Linux will stop existing how it exists today. So it triggered a bit of review, because for us at CERN, we are using pretty much CentOS everywhere. This was a distribution, a Linux distribution that fit it all. It was working for servers, for technical console, workstation, and as well for all the industrial PCs, known as front-end as well. So this workshop is born about on why it will what the decision with Red Hat and CentOS will change, and it triggered a review of what we can do. And even before that, for industrial PCs, looking at new architecture and different change in the ecosystem, we had started a renovation project just to see what was on available on the market. So the goal now of this workshop is for us and for other people, because this is why the first part of the track is really concentrating on CentOS, because we had a lot of feedback of people wanted to know what CERN is doing and how we plan to approach the changes. So we decided to add a bit a section at the beginning where my colleague from the IT department agree to present the view of IT for CERN. And this is a collaboration with Fermilab, because we always work with Fermilab in the Linux distribution ecosystem, as you remember, Scientific Linux. And so basically what we want today is to see what can be done. So this is it. What Linux distribution can we use in all the use case we have across all different institutes we have at this workshop today? And for that, thanks to the people who replied to the survey, because I wanted to do a quick cloud world of what is going on. And we still see that the main distribution that has been mentioned, so we got around 25 answers. So it's not completely, it's a little amount of people that did reply to the survey, but it just gives you an idea that a lot of people are interested in CentOS still. And it was very interesting to see the different distributions that people are using across institutes. So we see we have Slackware, OpenSUSE, Tinicore, Debian, of course, Ubuntu, Red Hat Enterprise Linux as well, and Rocky Linux as well. So for us, it was very interesting to have this view. And so now I wanted just to show you the program quickly. Let me just stop sharing. I will just share the Indico with you. Oops, share screen again. So just to remind you that the workshop is part of the ICALEPCS conference. So thanks a lot to the organizer for all the work that has been done. And it's only the beginning. All the plenary are next week. So enjoy the conference, and I hope this workshop will give you a good start. So the workshop program is such as this. We will have a first presentation about CentOS at CERN by Ben Morris, who is part of the Linux team in the IT department. After that, True will join me to discuss about the CentOS board. If you have questions, this is kind of ask me anything questions, and there will be 2 board members, so myself and True, that he will join us soon. And after that, we left a bit of time for questions in case you have questions around CentOS, especially in controls. So we can review. So I propose to start soon. So Ben, I will stop sharing. I will give you the floor.
Cool. Let me see if sharing works.
Looks good.
See a sharing logo.
Yes.
Good. Okay. Shall I start now, or do you want to wait a little bit?
I think we can go ahead.
Okay. 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 Everyone sees the titles?
Yes.
Okay. So thank you, Thomas. As previously mentioned, my name is Ben Morris. I work in CERN IT, and this talk will be primarily about the CentOS end of life announcement and what that means in the short term at CERN. In time a little bit to before the announcement was made, it was pretty clear what the direction would have been. Our existing production operating system, CERN CentOS 7, was going to finish mid-run 3. This is the LHC run 3. We needed a successor to that, and the logical successor was CentOS Linux 8, as it had an end of life of 2029, and thus pushed us through the entire run 3. But the CentOS projects made an unexpected announcement in late December 2020, where they stated that they will shift their focus from CentOS Linux to CentOS Stream, but more crucially, or CERN at least, or I guess most people in the community, is they reduced the life cycle of that distribution from being 10 years to 2 years. They did this mid-cycle, and that means that CentOS Linux 8 will end support in a number of weeks, in around 10 weeks' time at the end of this year. So if we go back to that same slide with this new information, see that the CentOS Linux 8 expires before run 3 starts, and its successor, CentOS Stream 8, has the same end of life as the predecessor, CERN CentOS 7. So we need to find some solutions going forward. But firstly, let's talk a little bit about what Stream is. In Red Hat's terminology, it's a rolling updates Linux distribution that will be used by Red Hat as the upstream for each RHEL minor release. One way of looking at this is the RHEL development is now done out in the open. It's done much more transparently than what it was done before. As before, what Red Hat would do is they would take a snapshot from Fedora, internally tweak and modify things, and eventually make a beta and then a release of Red Hat Enterprise Linux. And then CentOS Linux would rebuild from that source. Stream now sits between Fedora. So Fedora will always be the bleeding edge. Things can break every day, and that's kind of expected in Fedora. CentOS Stream is now the upstream for Red Hat Enterprise Linux, but it goes through the same QA processes as any package update to Red Hat would be. So it's not as bleeding edge as Fedora. There won't be any major point releases for Stream. When updates are available, they'll be released. Whereas in the Red Hat point release world, updates are clumped together into these minor releases, and then every 6 months or so you have a large update of packages. The life cycle of Stream is a 5-year term. Red Hat Enterprise Linux still remains on a 10-year term. But because of what I just mentioned, the transparency, the contribution back to the project, back to CentOS Stream, but also the enterprise release will be much easier than what it was to contribute to CentOS Linux. Because contributing to CentOS Linux basically involved you to go backwards. You had to file a bug report with Red Hat, go through the sort of Bugzilla process. And even then, a lot of the fixes were done behind closed doors. So going forward, Stream 8 will allow the community to shape the distribution going forward. And then, as I mentioned before, at the end of the year, there is no more CentOS Linux anymore. So if we jump to the present time, CC7 is still a supported operating system at CERN until the end of life of mid-24. We have a number of CentOS Linux 8 machines, which will still be supported until the end of the year. We were quite early in adopting CentOS Linux 8. So at the time of the announcement, we had several hundred machines. And we needed to find a way to extend the life cycle of those machines. The most obvious choice at the time was to provide a migration path for those machines to CentOS Stream 8. We supported CentOS at CERN in around May of this year. And you can see on the graph on the left, the uptake of CentOS Stream hosts in comparison to CentOS Linux hosts. We're now surpassing the system counts of CentOS Linux hosts. And that trend will continue as time goes on, as we get closer and closer to the end of life date of CentOS Linux 8. So you may ask, how do we do that, or what's special about the implementation? We try and keep things simple. We don't do any rebuild, so all of the stream content at CERN is upstream RPMs. Previously with Scientific Linux, we would do rebuilds, which incurred extra overhead on our side, but here we're using upstream. There is one small exception, which is we rebuild the release file, and this allows us to hard code repositories to use our own mirror, as we have some areas of don't have internet access, and this is an easy way to always force them to communicate to our mirror. And we have an internal build system for site-specific RPMs, which are signed with a specific GPG key, and that GPG key is included in this setup. So we provide a CERN repository which houses these RPMs as well as any other site-specific RPMs, but it's all upstream. And in addition to this, the other aspect we have is we in a way we control the release process. And what I mean by that is we have a gating system where we can promote content. And the gist of that is we have a set of scripts that run daily, and they create a snapshot of production of the upstream CentOS Stream content, and renames that into a new directory of the current day. So we use, again, simplistic naming here. So it's year, month, day. The script goes on to perform some internal validation testing. It checks to see if key package families that are crucial to us can be installed, because we want to make sure that if we're promoting a new snapshot, then it's not going to introduce a lot of pain. We rely on certain kernel mods, K-mods, so such as OpenAFS, which is used extensively at CERN. We ship the K-mod in our CERN repository. So our script rebuilds that if there's a new kernel release. And likewise, if there's a new release RPM, then we may have to manually update our version depending on what has changed upstream. So providing all of those test cases pass, we promote that snapshot to today's we promote that today snapshot to our testing repository. Now, testing repository is pre-configured on a subset of CERN hosts that will use that repository for their system updates. And this allows us to have a real-world testing, basically, of a proportion of the CERN fleet to confirm that those updates don't cause any issues. If they do cause issues, then we've got time to either pause the promotion process into production, or to adapt our script to maybe exclude a certain package that is known to cause issues, or include a previous release that didn't have this issue. If all things go to plan, once a week on a Wednesday, the snapshot from the previous week is promoted to the production URL. And this is where all of the other CERN hosts consume that content. So what this means in practice is, whilst Stream has more frequent updates, in some cases we might have daily updates, and I think with Stream 9 there'll be multiple updates per day even. Production hosts at CERN will only ever update once a week. Now, if this content that I've just explained here is of interest to you, there is a presentation scheduled at the next ICALEPCS in late October. If we have a look at more of the data side between CentOS Linux and CentOS Stream, this is a graph that I've generated from the weekly updates that we use at CERN. And you'll see straight away that the spikes, the red spikes, are the CentOS Linux point releases. So as I said before, the old model of lumping all of these updates into one large bucket and then releasing it periodically every 6 months or so is clearly seen here, where you might have up to 3,500 packages in one day, and then comparatively speaking, nothing until the next point release. Whereas CentOS Stream, the updates are released once they're past Red Hat QA, they're released. And you'll see that in terms of system package count, there's significantly more, but they're released in smaller chunks than the traditional point release model. This slide illustrates that a little bit in more detail. These are the three main repositories used in CentOS Linux and CentOS. And this shows the total number of packages in each of those repositories. So you'll see that in base OS, for example, there's more than double the number of packages in Stream than what there are to Linux. And what this directly correlates to is a faster iteration of change. There's more development happening in Stream than what there is released in CentOS Linux, or in Red Hat Enterprise Linux for that matter. I wanted to talk a little bit about security updates, because the model is for bug fixes and security updates in general. The code will hit Stream first, and then it would be integrated into Red Hat Enterprise Linux. And that example can be seen on the first item of this graph with the microcode update, where it took around 6 days for the update to reach Red Hat Enterprise Linux after it had been released in Stream. Red Hat has been quite clear, though, that for some security updates that have a security embargo, then they'll be released in Red Hat Enterprise Linux first, and then they'll filter down into other projects, such as Stream or Fedora. And that can be seen for these two kernel releases, where the delta in days from Red Hat Enterprise Linux to CentOS Stream and CentOS Linux was the same. They went through the same pipeline to release those kernel updates. And in the case of these Thunderbird and Firefox updates, you can see that the delta from the RHEL release to the Stream release was very short. We're talking 0 or 1 day delta. But on the CentOS Linux side, it took about a week for that update to be rebuilt and distributed through the mirror network. So I've been talking primarily today about what CERN is doing, but that's not to say that we're doing this alone. As Thomas alluded to, we're working closely with Fermilab and other HEPIC sites. We're continuing to analyze the scientific use cases for not just CERN, but for HEP in general. And we've been in the process of writing a joint statement on our findings, which will be published shortly on our linux.cern.ch website. It was unfortunate that it wasn't approved in time for this presentation, but it will be approved in time for the next presentation at HEPICS Autumn, which the link is described there. It's safe to say that the Linux distribution landscape is complicated, and I think we've outgrown this one-size-fits-all approach. Different use cases call for different distributions now, so it's inevitable that multiple distributions will need to be supported and used. If we have a little look into the future, we know that Stream 8 end of life occurs roughly the same time as CERN CentOS 7. So we still need to find a solid solution for the next operating system after Stream. So there's a few options that are coming to the table that are being in the process of being available now or are still being evaluated. CentOS Stream 9 is process of being released. It hasn't been released officially, but it's gaining traction there, and then I would think before the end of year that is released. Since the CentOS Linux announcement, other Linux clones have popped up. Rocky Linux and Alma Linux are the two most prominent here, but there are others. And the Red Hat Enterprise Linux itself is potentially an option for some use cases. We have been involved directly with Red Hat discussing an academic site license for CERN and CERN partners and what that would mean and what use cases it would satisfy. But I can't discuss those details today. So in summary, the CERN CentOS 7 is still a supported operating system. Stream 8 is the recommended operating system for new installations. Everyone should be aware now that CentOS Linux 8 end of life is in 10 weeks' time. The migration to a different distribution, CentOS Stream 8, for instance, is strongly recommended to continue receiving security updates. Stream 9 will be supported by CERN once released, and the option of using RHEL on site under an academic license is being discussed. It will be useful for some use cases, but it's unlikely to be adopted as the default Linux distribution. And with that, that concludes my presentation. I think we have time for questions though.
Yes, we do. So thanks a lot, Ben. Very nice presentation. Thanks a lot for your time. And let's go for questions. Let me open the chat window and see if people have questions. So please raise your hand in Zoom as well, so I can see if we have questions around CentOS. Okay. I don't see any for the moment.
On the chat, what about the concerns of stability of CentOS Stream? There may be concerns, but at least in our experience at CERN, we've been running production workloads across diverse environments now on Stream for several months, and we haven't seen stability issues. Let's put it that way. More so than what we would have had with CentOS Linux. Sometimes we would need to hold a package back, but we had the same issues with CentOS Linux. And the thing with Stream, now we're getting the fixes quicker. So it's better in our current experience.
So just to add to that, we had few experience as well where having some kernel in advance of the release of RHEL help us to support newer hardware and things like that. So we see as well an idea that a stream could help us to, what Ben said, to have fixed a lot earlier, and to be sure that they are included in RHEL in the future. So for us, we see it as well as a positive point, and it adds some burden on the management. We understand on how you do your Linux, how do you control your release, your Linux distribution. But for us, it has not been a big blocker so far. There is another question in the chat for Ben. What's the schedule for CS9 release at CERN, if you have one?
There is no firm schedule, but we're getting pretty good now at new distributions, because we started a process with CentOS Linux 8. We adapted it slightly for CentOS Stream 8, and we're already starting that process again for CentOS Stream 9. So let's say that most of the engineering side of the release process is done, but we don't have a firm date. I would say first quarter of 22, but I can't be more specific on that point.
Any more questions? Go ahead, we still have time. One more question in the chat. So any opinion on Rocky Linux led by Gregor Kurzer, the original CentOS founder?
So I did have slides on both the comparison between Rocky and Alma, because we have spent a lot of time internally analyzing those distributions and how they match with CentOS Stream, but we don't have those systems running in production. I don't have a strong personal opinion. I think that Rocky Linux is doing all of the right things to become a successor to CentOS Linux. They're being transparent with the way they build their distribution. And when you compare it to Alma Linux is trying to do that, but they're a little bit less transparent because their build system is not as open as what Rocky's is. We are using Stream 8 in production today. We're encouraging people to try Stream, but the good thing about the 8 family this current period in time with Linux distributions, CentOS Linux 8, CentOS Stream 8, Rocky Linux 8, Alma Linux 8, RHEL Enterprise Linux 8, they're all very similar. They're all from the 8 family. And if there was a requirement to stop using Stream and to move to Red Hat Enterprise Linux 8 or to move to Rocky Linux 8, then it would be a trivial migration path. It would be a process of changing system repositories, upgrading RPMs, rebooting into the new kernel, but it wouldn't involve necessarily a full system reinstall. So our current stance is we're keeping an eye on Rocky Linux and Alma Linux as well, how these communities evolve, because they are quite young still. They both had stable releases for 8.4. Alma now has a beta for 8.5. RHEL 8.5 beta was only released last week, so Alma is quite quick there. But we need to see if that traction continues.
Thank you, Ben. So the following question is, how do you manage such a continuous OS change with third-party software suppliers while usually provide support on their products only on stable releases?
We don't have such a concern at the moment. I guess the majority of the fleet of the system counts I was showing you were more open source systems, so that they don't have a commercial impact on top. this is one of the reasons why CERN is looking at Red Hat Enterprise Linux, which would potentially satisfy these arrangements at CERN at least. So for other sites, I don't know how that will play out, but probably if enterprise Linux support is required, then the options on the table would be Red Hat Enterprise Linux, Alma, or Rocky. Stream, it's really up to these suppliers if they're willing to support Stream.
And for CERN Beam's department, we are looking as well on how we can talk with our providers to see if they would like to support Stream or not, but it's still early. And it's the same with Rocky. Not everybody heard about Rocky, Alma, and everything. So I think we need to give a bit of time to provider to see how software provider manage this situation and how we can improve a bit their knowledge about the different OS. And we still have some backup plan to use containers to contain some applications. So we are looking at different ways, and we'll be happy to discuss it a bit after if you want.
Yeah, I think it's safe to say that the enterprise moves at a much slower pace than the open source world. And these community rebuilds of Rocky and Alma have only really been available in a stable setting for a number of months, 4 or 5 months. And that's a very short time for commercial software providers to get on board and to test their products with.
Thanks, Ben. So I think there's no more question. So I'll take a moment to thank you again, Ben, for all the work, and was very interesting presentation. And the plan is to move to the next presentation, which is more a discussion. So I hope you are ready to ask more questions. I am part of the CentOS board of directors since a year, and I thought it would be interesting for people to ask questions, because this is what body deal with CentOS governance. And so I invited True. True, are you around?
Yeah, yeah.
Hello, True.
Hi.
So thanks for joining. I try to find you on video. Yeah, you're here. Excellent. And so True is on the board since a long time. And we thought that we would take a few minutes to know if you have questions around the CentOS governance or things you'd like to discuss with us, board members. So I joined CentOS board. I will just go through my presentation. I was working in the CentOS community, mainly on the infrastructure for around 7 years with CERN. Mainly, I was working with CERN IT, same team where Ben is now. And after we just transitioned from Scientific Linux to CentOS 7 when I was in this team. So after a few years, after 6 years, I've been offered a position on the board of directors to steer a bit what is going on in CentOS. And it has been a great experience since last year, and we could work on a lot of different points. So this was very interesting for me. I don't know, True, if you want to go for a quick introduction.
I've been in the CentOS team since CentOS 3, so I built the 64-bit version for AMD64, and I've maintained 3, 4, and 5 with Johnny for 10 years. Then when Red Hat took over CentOS because we had some, let's say, financial issues, I took the back seat and just looking at as a board member, try to help as much as I could during my free time here in Pasteur. So I'm very happy that Thomas joined and provide new blood and new incentive, new push for the board to evolve and meet the community needs. So we all know that the 8 stream was difficult to be accepted, but I think it was finally a move for the best of us. So let's see how things evolve in the next years. definitely when 9 lands, I think that we have a better view of what people want and what people don't want, and if we manage to get a new bootstrap for the CentOS community. Please ask any question if you feel like.
Yes. So anybody, any question? Don't be shy. Do you want to know something, some process? No? Come on, come on, come on. Don't be shy. I'll put my video on to bring people. So you really have no questions. So I wanted to just share a bit what we are doing, maybe to show you that being on a board, the idea is to try to help everybody that contribute to CentOS to do it in a safe and nice way, and to be able to direct the different people in some direction when they need help. And on top of that, the board is composed with Red Hat liaison, which help us to do the interface with Red Hat, who is providing the manpower for few projects. And so this is basically trying to get everything together and to provide a good experience for contribution. And since the beginning of this year, we have been trying to make all the process more transparent. I don't know if you are aware, but since July, I think, we record the board of director meeting every month, and we publish it. All the agenda is not transparent, so by default everything is not transparent and available for discussion. And the board meeting took place yesterday, and 1 week after the board meeting, now we have an IRC meeting where people can ask questions about what is going on in the community. So we are closer to people, and we try to give them tools so they know what is going on, to avoid a bit what happened with CentOS Linux 8 and the misunderstanding and the big change that was not received very well by the community. So we are trying to improve as well this part. So for me, that's it. So no question yet? No? Stefan, hello. So what is your opinion on why the CentOS stream change was so difficult to get accepted? True, do you want to go ahead first?
I know what the biggest decision at this point. I think the hardest thing was when we decided to announce a stream was the only solution within next for 2022. I think that's the biggest hurdle we had on the board, trying to convince Red Hat that we should modify the initial plan. But since the decision came out, and with the community fight or whatever you want to say, and the spawn of the clones, I don't think there's any major decision that was hard to be taken. Everything was consensus, and most of them was unanimously approved. So
yes, I think
you feel very different, but
no, I don't feel different. The decision was taken, and
it was hard to be taken when
it was hard for everybody. Yeah, I don't think it was something that this was taking the decision and negotiate with Red Hat good condition for stream as well, to get a good stream and to get contribution. So to make CentOS contribution oriented to change, because CentOS has a big user community, if you look at it. And in terms of contributors that contribute to CentOS, it was really a little amount of people. And we know that as well, it was because maybe the community contribution were not handled in a way that, so this is why we're trying to improve now the process to get more contributors. And one of the questions was talking about SIGs, and the special interest group is something that is taking a new direction for CentOS. Basically, it means that people can contribute packages or documentation or infrastructure bits in a more central way, and we kind of delegate, because the role of the board is not to contribute directly to CentOS. We all did in the past. We are still doing sometime, but the goal is really to try to make it easy to contribute. And the special interest group now have the responsibility to onboard people and to let them work on what they need, and to come to the board every month to ask for something in the need. And the special interest group, there's few groups that have been created recently that are quite interesting. I'm thinking about the hyperscale one, which is led by one of the board member who is working as well for Facebook, Davide Calpada. And the SIG basically provide a newer version of systemd and some fix in the kernel. So this is what Facebook use in production, but basically now they push it first to the community, and after they're doing their internal build. But there's no more secret on what is done. And it was already the case before. It was available on some repository. So Facebook always publish their change, but now it's really in the framework of the hyperscale SIG, sorry. And it add a lot of people to the community. Some people from Netflix have been joining, some other people from other company, and we are still keeping an eye on what is done in this area, and to know if it could be a good fit. I hope it replies to your question. And yeah, I think we went through this one. Biggest decision, thank you. So you have question around CentOS. What I will do is I will take your question just after, because this question is more related to CentOS and not the board member. So then I can live through going back to his work as he's busy.
I reply for myself.
Okay.
Because I'm using CentOS, obviously. So.
Okay, thank you for the reply in the chat. I didn't see, so that's perfect. So yeah, we here at CERN, for example, we don't use GNOME as default. We move to XFC from EPEL, but well, yeah, we can talk a bit later in the Q&A if you want. So I'm checking the question. Any other question in the crowd? We have still a few more people that join, so that's good.
I think the main question is that we're not visible enough as board members what we're doing and what the purpose of the board, excepting have a nice title, and we meet every month at 10 p.m. local time, which is late at night for us and early for the other guys in the US. There's only duties, nothing very fancy at the board level.
Yeah, this is not like something you would think about a mega party and things. It's
a diamond card that you show away and say, let me in.
Exactly. And if you want to have a look to the meeting nowadays, you can have a look on YouTube. There's a video and you will see it's not that exciting. But still, we are moving forward. There's proposal for refreshing the logos and things like that need attention. More SIGs are proposed, like the automotive SIGs and other communities that like to build around CentOS Stream. So as well, we still see
I think the K-mode 6 should be emphasized.
That's true. Mm-hmm.
One of the main issues we have found with Stream is the lack of stable ABI within the release time. So if you have a driver that's supported for rare and it might be broken during the Stream 8 lifetime. So the K-mode SIG is there to fix and push the issue and solve it, hopefully.
Yeah, and they work in collaboration with the people doing that in the community for a long time.
Yeah.
So this is really positive, and we hope to see a bit of driver fix in there and newer things in this area. So yeah, good point, True. Thanks.
I think that would help Stream 8 merging or during the lifetime of Stream 8 and offer an alternative to the downstream code that CentOS Linux used to be. So everybody can profit of this work if everything goes as planned.
Yes, I will add the link on the Indico page. If you're interested in the SIG, I will add a list of SIGs we discuss. So you can click on the link later after this workshop, and you can see if something is of interest. And again, don't hesitate to contact us if you want some info, and anybody on the board. You have less people now because of the time zone, because I'm pretty sure a lot of people wanted to join, but in the US it's quite early. So next time we can get more board members if needed. But thanks a lot, True, again for joining.
Yeah,
that was very nice. And now we are almost at the end of this first session about CentOS. After we'll be moving to Linux distribution in controls, and Federico will start with a presentation and an evaluation of what has been done at CERN. But we still have 10 minutes for questions or for a break if you don't have more questions. I mean, now it's time to shout if you want to talk about CentOS, something at CERN, something in controls, something you would like to know about our process. So if you have any question, please raise your hand or just write it in the chat if you feel like writing. Okay, no question. I'm looking at all the attendance. So far, so good. So I don't see any question. No raised hand. So I propose that we do 5-minute break until the beginning of the conference. I don't want to move it forward because the notification in the application of the conference will not notify everybody that want to join. So if it's okay with you, we can wait until 3 to start the next talk. Is it okay?
Yes.
Thank you. So I'll see you in 5 minutes. Hi again. We still have a few minutes before the next talk. Just in case you still have things to ask, don't hesitate.
So Tom, I take the occasion to ask something.
Go ahead.
Yes. So is the CentOS community keeping track of some statistics about the usage of CentOS? For example, is used mainly for web services or it's used in automation, automotive, different industries. So do you have such a statistic?
Unfortunately, not directly, I would say. We have the mirror statistic from who is downloading CentOS, and we can do stats on that. I would have to find out when the last time that was done. I will ask. This is a good point, actually. And you can know which kind of people are mirroring CentOS, and you can get stat out of that. But in terms of community working, it's more like the people that show up on IRC. So we have the usual suspect knowing that are working on typically Facebook, typically CERN, typically I don't know, a few others, big institute that are working, Fermilab, for example, not forget them, and other people working around the CentOS area. But no, for the smaller, let's say for people that didn't contribute directly, we don't have a way to track them. And I think that could be something of interest to try. Go ahead.
Have you ever thought about running a survey, try to get to be more knowledgeable about your users?
So this is one thing. It's a good idea. The problem is, how do we reach our users? Because this is one of the challenges. CentOS has few contributors, and in terms of 100K users, right? And these people, not all of them are subscribing to the mailing list. Not all of them are on IRC. Not all of them. So this is as well very hard because CentOS has become something you consume very easily for the past 10 years, and we don't have a central way on knowing exactly who is doing what. But I can certainly bring that to the community manager of CentOS, and if he would like to try to organize something, because I think it's a good metric that we could have, and it would allow people to meet different industry working in the same area or thing like that. So different companies are working in the same area. So yeah, it's a good idea. I will bring it back as an idea for the next board meeting. And I will check what is done. If I find some links, I will just add it. If we have at least the mirror thing, I think it was done, but I need to confirm with you know.
So do I start sharing my screen?
Yes, I think we can go ahead. It's pretty much time. So if you can wait like 1 more minute just to give time in case people click on the link directly when they get it in the application.
I'm just going to share the screen.
Go ahead.
Can you see it without artifacts, without these black boxes?
We just have the black box on top. Yeah.
Yeah, but yeah, that one will disappear.
Excellent. Thanks.
So should we start or we wait a bit?
I think now we can go ahead. It's 3:01. Let's go.
Okay, then. So good afternoon, morning, evening, wherever you are. So I'm Federico, and I'm working at CERN, in particular in the BIM department, the Control Electronics and Mechatronic group, in particular in the section responsible for electronic design and low-level software. And about me, I'm specialized in Linux kernel development and Linux setups. So just a glossary to avoid confusion later. Whenever I will speak about Red Hat Enterprise Linux, I'm including also Alma, Rocky, and whatever derivatives, and the CentOS stream as well, because as Ben said before, as of today, there was not that many differences. Instead, when I will speak about Debian, I just mean Debian. And for those who don't know, vanilla Linux kernel is another way of saying the Linux kernel available at kernel.org. Finally, front-end computer, FEC, it's a terminology we have here at CERN to identify computers controlling and monitoring accelerators equipment. So when I speak about FEC, I'm not talking about servers, workstations, nor consoles. So let's move and talk about front ends. So just to give you a bit of context, a front-end computer is made of a single board computer where the CPU resides, and a number of hardware modules to extend the front-end computer capabilities. And each of these module is connected to a piece of equipment controlling or monitoring the accelerator infrastructure. Then some of these modules can be used also to extend the capability of the control system over some sort of private network or field bus. And then here we will find new nodes connected to other piece of equipment. The type of CPU that we have, it's Intel. So we only have Intel processors. On the other sides, we have many type of buses / form factors like VME, PCI, PCI Express, USB, PXI Express, or micro TCA. So it's very heterogeneous. And then we run CentOS 7 on top of this. The original plan, as Ben already said, was to use CentOS 7 and then to move to CentOS 8 and then probably to CentOS 9. But this is now not possible anymore because CentOS 8 end of life is foreseen for this year. Instead, we have a different path. So the stream path, so 8 stream and probably 9 stream in the future. But this turbulence gave us also the opportunity to think about if this is what we really want in the future. So is there life outside the Red Hat Enterprise Linux, something that could fit better our needs? Because according to DistroWatch, actually there are hundreds, thousands of different distributions. And then since we are at it, our workflow concerning how we use the operating system and how we develop for it, we install software, we boot it, and the tools that we use, can we improve what we did in the past? So the idea about renovating the FEC operating system starts first by reviewing the workflow surrounding it, and then take a decision about the distribution and then tools. Because first we want to know how we want to work in the future, and then to see if one of these tools can actually help us in achieving these goals. So let's first have a look at the current workflow and what we can improve there. Since a long time, this is the workflow that we had. We have sysadministrators preparing the OS and then deploying it in a shared environment. The OS, the Linux kernel, and then the deployment environment, it's all shared between industrial PCs, FEC, and developers. So the typical workflow is that developers, they will access the shared environment to develop their own software. And then later they will release and deploy again on the very same shared file system. This workflow was designed for a few hundreds of homogeneous machines, and it was designed long ago with the technology available. But this workflow today is actually applied to more than 2,000 not homogeneous machines. It doesn't really scale, and it's limiting the adoption of standard and modern solutions. So the main issues of this workflow are highlighted here. So first, the fact that we didn't standardize really the deployment mechanism. So we could find different artifacts deployed with different mechanisms using different tools in a non-standard file systems. And this makes difficult the sharing. So it's difficult to distribute software in other contexts or in other institutes. Then we don't have a formal dependency management. So it's a bit hard sometimes to coordinate deployment. Then, as I said before, the environment, it's shared and it's on CERN servers. So it's hard to replicate it outside. And you need a CERN connection, for example, when teleworking. Then these artifacts are, let's say, manually deployed, meaning that there is not an automatism that brings your artifact from your development process to a release stage and then to deployment. And finally, again, because everything is shared, we can face problems when developing, especially when we have concurrent developments, because if a header file changes while you are developing because someone else is actually developing on this header file, we can trigger a bit of conflicts. And then any software is available on any machine, even if it's not needed. So software A for the PC A is actually available everywhere, even if it's not used. And or again, for the same reason, it's hard to have exceptional installations. So this software, you cannot really install a software for a single PC. It's shared, so it's everywhere. So let's have a look at how we think to solve each of these problems. The first two, we are planning to use a standard solution, so software packaging. So with this tool, we can handle dependencies formally, and it will be easier to distribute software with different institutes. And it will allow us also to put in place a set of uniform policies for all type of artifacts without having different ad hoc tools for each of them. Then about the development environment, we are thinking about creating a software development kit. So something that can be produced and distributed. So you can install an SDK on your PC, and then you cannot be perturbed by concurrent development happening in the next office or on the other side of the planet. It will allow us to work also without the connection to any CERN infrastructure. So it should improve the security. And it could also standardize the development for everyone. About the fourth point, manual deployments. We should all know that continuous integration, DevOps, they are really improving the workflow of many companies and developers because it's today the standard solution to build, test, and deploy artifacts. And we would like to propose this in the control system to both improve the software reliability, but also to implement automated delivery policies. For example, out of a continuous integration, we deliver automatically in a development repository, whatever package we produced. And about the last point, what we would like to do is to really isolate each machine. So each machine, in other words, each machine will have its own file system that nobody else can touch. So if you want to install an artifact on machine A, it will be much easier and secure, safe than before, because we have a finer control on installation, software upgrades. We will be able to handle exceptions or having different versions according to the different systems. So the general idea is to move away from this workflow and having something more similar to this workflow, where things are, the development and release process is decoupled from the operation. And here you can see it at the level of the continuous integration and the repository. So people release on the repository, and the continuous integration fetches packages from the repository and produce images. And then ideally, whatever is in the square, in the red box is or will be automated. Moving then to distribution and tools. So first, requirements. Already the workflow gives us some requirements. So we want to be able to package software. We want to be able to produce and use a software development kit using continuous integration and continuous delivery. And we want to be able to isolate frontends. Back to this overview of the fact tier, I have to admit that I lied a bit, because the situation is a bit more complex, because it's not only Intel, we have ARM systems as well, where we run Buildroot and Yocto images. And on the other side, because of these embedded systems, we can have really custom systems with custom connections that cannot be standardized. And just a little parenthesis, what about RISC-V in 5 or 10 years? Will it be used? Will we start to developing using this processor or not? But as of today, the hard requirement is to support Intel 64-bit and ARM 64-bit. Then for this type of machines, we do a lot of in-house hardware development, and not only hardware modules, but we also produce our own crates. And for example, on these crates, we have Intel Core i5, and in the other one, we have the Xilinx Zinc UltraScale Plus. And as you can see, we have also modules having the very same SoC. And because we do all this hardware development, we also need to have full control of the lowest software level. And this level is the Linux kernel. As of today, we use the kernel from CentOS 7, which is maintained by Red Hat. And as of today, it's the version 3.10 from June 2013, where Red Hat applied 10,000 and more patches on top. This makes it quite divergent from the vanilla kernel from kernel.org. And our experience proved in the past that it constrains our driver development capability, but also our debugging capability, because we don't have really full control of these 10,000 and more patches. So sometimes we don't know what is happening. We have to inspect the source codes, but without knowledge about their history. Well, it's not completely true, but it's let's say, harder. While instead we would like to use a vanilla kernel because it will allow us to exploit internal features by moving some of our modules to be inside the kernel, because otherwise some development outside needs special hacks. It could improve the debugging capability and also the adoption of modern hardware. And by the way, even if we go the vanilla kernel way, vendors and the distribution maintainers, they participate as well to this community. So if we don't meet them through the company or through the community, we will meet them anyway in the Linux community. And as of today, what Linux offers as a long-term stable kernel is the 5.10, which should be supported until the end of 2026. So not only hardware, but we also do a lot of in-house software development. On FEC, most of the software that runs on it, it's developed in-house. This means that our requirements from the distribution are very little. So the standard C, C++ library, Boost libraries, libraries to parse files, scripting like Python or Perl, and very few others. And also on the side of services, we are not really demanding. So something for authenticating user, sharing file systems, monitoring the health of the machine, logging, and very few others. And then last requirement is that we want to be able to customize this image, the distribution of choice, so adjusting configuration files, installing, removing packages from the distribution, but also from our internal repository, manipulating the booting sequence, and of course, at the end, testing all our customizations against real machines, and possibly to automate all this process, both building and then testing. Moving to the Linux distribution, we ended up talking about the usual suspects: Red Hat Enterprise Linux family, Yocto, and Debian. But to be honest, from the pure technical point of view, it doesn't really matter, because our requirements are so little that any distribution would do. So what we're looking for to actually make a decision are other points, which are perhaps not really technical. For example, for the Yocto project, what we can say is that you can build exactly the distribution you need, optimized for your CPU, whatever your CPU is. And is usually supported by SoC vendors, so meaning that if you go to NXP or to Xilinx, they will offer you as well a meta layer that you can add to your Yocto recipe to build your distribution. And out of the Yocto building process, you will get an SDK to distribute to your developers to produce software for your Yocto image. On the other side, we have to say that it has a very steep learning curve, and it doesn't offer any, well, until last year, it was not offering any long-term support, but since last year, we have a 2-year long-term support of the tool and the basic image. Plus, it's expensive to maintain, because Yocto helps you to produce the image, but then the maintenance is up to you. So upgrading, bug and security fixes are left to users. And finally, the CERN infrastructure is not really ready for the Yocto development. All things mentioned by Ben before about the infrastructure, snapshots, release and so on. Of course, this is not available for Yocto, because at CERN we are more focused on the Red Hat family. These 2 points are enough for us to say that Yocto cannot be the way, because we don't have enough resources to maintain ourselves a distribution in the long term. So about Debian, we can say that its Linux kernel is very close to the vanilla. So if we build our own Linux kernel using the same version, then we shouldn't expect any surprise from the user space level. And then extended support can be sponsored if needed. So Debian provides 3+2 long-term support, but you can pay, you can put money on the table and you will get more support to 6, 7 or more years. Then it supports many different CPU architectures, not only, for example, ARM64, but also ARM32, and we have some systems running ARM v7. And it's very common to find Debian on embedded systems, so on SoC and similar. And again, the cell infrastructure is not really ready for Debian development, so we don't have this the same infrastructure that we have today for Red Hat. So this would require some additional work. And then on the Red Hat side, we have this infrastructure, it's ready, and CERN is really knowledgeable about Red Hat Enterprise Linux, and we can reuse a lot of internal knowledge. Plus, the Red Hat offers 10 years of support of its distribution, and the same goes for probably Rocky and Alma, and not for CentOS 8 Stream, because it comes before in the process. On the other side, you cannot really get support from Red Hat if you don't have a contract with Red Hat. And even if you get a contract with Red Hat, by changing the kernel or changing other packages, you lose the support, or at least they will ask you to reproduce the problem on what they sell. And this could be a problem for us. And as I mentioned before, the Linux kernel that is offered with Red Hat Enterprise Linux and derivatives, it's quite far away from the vanilla kernel that we would like to use. This little table tries to summarize what I just said. I will leave it for you for later. Moving to how we would like to build these two distributions, so Red Hat based and Debian. So we are evaluating mainly two tools. The first one, it's Packer. It's maintained by HashiCorp, and it's a general purpose tool that allows you to generate any OS image of any version. But because it's a general purpose tool, it does not know in the details of your distribution of choice. And for this reason, if you want to customize it, you have to implement your own plugins or to provide scripts that helps Packer in customizing your image. And then for the very same reason, because it's general purpose, it cannot generate an SDK of something that it doesn't really know. On the other hand, for Debian, we are considering ELB, which is a tool maintained by Linutronics, the same company behind the real-time patches. And this tool allows you to build a Debian image, and only a Debian image, whatever version but Debian. And because the tool is knowledgeable about Debian, it knows about details. And because it knows about details, it knows also how to build an SDK automatically out of it. And it doesn't need any scripting, because everything can be described in a single configuration file. Moving forward to the last part. So once we have the distribution, once we have the tool that we want to use to build this distribution, we want to automate it in continuous integration. And the tool that we are going to use is the GitLab CI/CD. Even if our department provides a Jenkins container, if I'm not wrong. But anyway, since we don't have a strong requirement yet on the continuous integration, we will exclude Jenkins, and we will use what is officially supported, completely supported at CERN, which is the GitLab CI/CD. So moving to the end, so to the conclusions. On the workflow side, what we want to do is to modernize the workflow surrounding FEC, to make use of standard Linux tools and best practices, and to automate as much as possible of this. And we will try to do it by packaging our software, isolating FEC file systems, introducing SDKs, and making large use of continuous integration and continuous delivery. About the distribution, as we said before, we want to support 64-bit Intel, 64-bit ARM, possibly using vanilla kernel, and to avoid at any cost the maintenance, so applying security and bug fixes ourselves. We would like to rely on a distribution. And the minimum support that we need is at least 5 years or more. And for this, we are evaluating Debian using ELB as a builder, and CentOS 8 Stream with Packer as a builder. As of today, what we did is to evaluate distributions. We also thought about Arch at some point, but it doesn't support ARM, so we excluded it. we evaluated also build root and OS tree as tools to handle operating systems. Sorry, and and about packaging, of course, the most two popular package systems, RPM and Debian. So we spent a bit of time to understand how we can better exploit them. We also tested different ways to isolate the different machines using the network block device, network file systems, or a live SquashFS in RAM. We also created a virtual FEC in QEMU with a virtual timing receiver, allowing us to test almost the entire software infrastructure on top. This is not completely tested, but it could be very useful in continuous integration because you will not need any real machine. Everything could run in the runner. And finally, we optimized our booting sequence, our network booting sequence, because I realized that right now that I forgot to say that FEC are diskless, so everything is booted over the network. So we optimized the bootloader, but also all the init from disk process. And for the future, mainly for the next year, what we think is that in the Q1, we will be able to provide a vanilla Linux kernel for both Debian and CentOS Stream, because we want to keep the door open to both possibilities. And then in Q2, actually take a decision about Debian or Red Hat Enterprise Linux distributions. And finally, based on this decision, to optimize the building process around it. And in Q3, we believe that we will have a fully working FEC with a new distribution. And then for later, we will leave all the improvements about the workflow. So starting packaging, isolating computers, start using the SDK, and so on and so forth. So I'm done with the presentation. So if you have questions, comments, or you just want to chit chat, you can reach me at this address. Thanks.
Thank you, Federico. So the rest of the hour is dedicated to talk about Linux in the control. So we can start to take questions directly to this presentation. And after, I have a list of questions that have been submitted through the survey that we can go through. But I would like to start with questions around this presentation. So please go ahead, raise your hand or write the question in the chat. So
the question from Remy, by using the vanilla kernel, does it mean upgrading it more often? So I would say that it's not really related to the frequency of upgrades. So by choosing the stable release of a Linux kernel, the community periodically release patches, and then it's up to us to decide when we want to upgrade. Then we can add that if we have full control of this process and we optimize our process, we can also think about not just stick to a stable release, but also to moving to the next stable release earlier and not waiting 5 years or whatever.
So the next question.
Paid version. Yes, CERN, I think, uses the paid version.
Yes, this is a community edition, and there are discussions around that that are going on right now that I can't give you comment because it's managed by the IT department. But if you have interest, we can redirect you to the right people that can give you more details. So, another question. Go ahead.
Intel SoC provide Angstorm distributions. Do we get support for this regularly? Honestly, I don't know. I know what you are talking about, but I don't know if there is a regular support from Intel. Then is Flatpak considered for package management? So Flatpak and Snap, I didn't consider them because I'm not really considering them pure package managers because actually they do more. And yeah, it's well, the short answer is that we don't consider them. So just RPM and Deb and not Flatpak or Snap. We can elaborate more later, but right now I don't have, I think, all the answers to this. I have considered them. I had a look at this. In particular, I had a look at Ubuntu IoT, and with Ubuntu IoT, actually what they offer is Snap. Instead of Debian packages, they offer Snap packages. But the way they work, it's a bit layering a different file system one on top of the other, mounting. Honestly, I'm not really used to that. And as the Debian community says, it's a way to, it could be a way to not maintaining properly your software, because by using, for example, let's say Snap, and you package together all the libraries that you need, then it's up to you to provide the upgrades for these libraries, because you will not get the upgrades from the OS. So you're responsible for the full package. Instead, if you package properly your software against the distribution, then part of the work is done for you for free.
I will just add something on that. Flatpak and Snap are really more oriented to be user-friendly, to install application by clicking on an icon and things like that. So I think that in control system, this is not really the use case. Flatpak is great, I'm using it, but I think the goal of Flatpak and Snap is a bit different than what we need in a control system. And as Federico said, we already have the package manager for each distribution where we could package what we need. So for us, I don't see a big advantage to be using Flatpak or Snap.
Honest about other question, was SUSE distro considered? Honestly, I didn't consider it, because the reason is that, as I said, actually any distribution would do. And SUSE, it's apart from the let's say the administration part, so the company behind it, it's very close to the Red Hat one, I would say. So that's why I didn't consider it, because if we have to go SUSE, why not Red Hat? So it doesn't, I didn't notice, at least myself, a big difference that would worth the evaluation.
Any other question? I'm checking if people have some hand raised or not. Looks like not. A new question. Federico, I let you read.
And Intel SoC, do consider having Linux distribution compatible with their CAD tools? I cannot answer to this question, because I don't know, not because I don't want.
Yeah, me neither. Sorry that I don't know.
So, other question, which parts of the control software will be focused for packaging and CDCI? So, no user interface, because on front-end computers, we don't have it. So the user interface, it's elsewhere on other machines. So this is out. Mainly drivers, firmwares, low-level libraries to control our hardware, and then going up in the software stack, the middleware, timing services, the FESA, our framework to handle devices, mainly these parts. So then it will be it will be responsibility of each team to decide how to go about CI/CD and packaging. So what we want to do as let's say OS providers for this type of machines is the infrastructure, the knowledge, templates, so that everyone can build up their own packaging and CI/CD.
Just to take a step back from the front end, but for us as well at the system administration level, we would be really glad if we can package everything, because it simplifies your life. And that doesn't necessarily mean only RPM Debian package, but having guidelines on how to package is something we are looking at as well.
There is another question.
There was another question, yeah, from Frank.
Yes. Don't vanilla and builder flexibility require additional and distributed expertise in the different CERN groups? The vanilla kernel, not really, because this is what CERN was doing before 2014 with SLC5, at least. So we were building our own kernel from kernel.org and customizing it for front-end computers. So we were doing it, and it was working for a long time. So I don't think that this will add complexity, because we have the expertise to handle the vanilla kernel. And then about the builder flexibility. As of today, we already have a process to build a CentOS 7 image and customize it. So the builder just make it a bit more formal, and it will assure that we can build exactly the very same image, while this is not really possible today. And then it will be not something developed at CERN, but something a bit more standard and used, for which we can get support, and we can focus only on our business. But it's true also that it will require a bit of additional knowledge. Not for the different groups, mainly for the control groups. So not the equipment groups.
So one more question. Do you want me to take this one?
Do you use tools such as Ansible or Puppet in your workflow? So concerning front-end computers, in the future, this is a possibility, but we didn't think about it yet, because it's a decision that we can take later in time. So it's not absolutely relevant right now to take a decision about Ansible or Puppet. Then, and here Thomas knows much more, Ansible, it's used to handle our infrastructure.
Yes. So for the sysadmin administration part, we use Ansible everywhere, and we configure every morning all the server and technical console. So if you remember at the beginning of the presentation, but for the fact, as we boot everything from NFS, Ansible is not directly used in this workflow. However, Ansible is used to configure different parts of the infrastructure, if you want. So we have a lot of expertise with Ansible, and if at a point we will need to run Ansible with the front-end computer, it will likely be not a problem, and we already have the expertise at CERN. So, no more question for Federico? Ah, yes,
Containers.
One more.
Do you plan to use containers? The fast answer is no, because we don't see the added value of using containers at this level of the control system. So in other places, it could be a solution, but at the level of the IOCs, FEC, or however you want to call the computer next to the equipment, the accelerator equipment, no. Because it adds an additional virtualization layer for no real reason, at least in our context. But Remy, who he's around, can say more about this.
Yes, thank you, Federico. And next week on Thursday, there will be a 15-minute presentation on containers in controls. So it will be the state of containerization in Sun accelerator controls. So we will use them on technical consoles and servers, but yeah, indeed, on the front end level, it's not really, there is no plan for it.
So another question, with this approach, do you expect having to maintain multiple CERN control specific distributions? No, the answer is no. So the distribution will be one. It could be that the configuration could be slightly different, because with this workflow, we could customize one machine, meaning that you don't end up having CentOS on one machine, Debian on one, and Yocto on another. The distribution will be the same, only that in one you may have an upgrade that is not available in the others, because you want to test it first on one specific machine and then to distribute it to the others, for example, or because you need that software only in that context and you don't want that software to be available in other systems. So these are the type of differences that you will see, but not having multiple distributions.
Okay, so I think thank you a lot, Federico. We finished the session. It was very nice. Thanks. And we have an additional 15 minutes to discuss a bit about controls. And I had a few questions that were sent in advance. So Federico, if you don't mind, we can maybe share a bit of answer around the question for controls. One question that came back 2 or 3 times was, what about security in the controls? If we are looking at improving the security around the control at the distribution level, scanning, network scanning, and things like that. So as a reply, I would say that we always try to improve, and not only for the control directly, we are trying to find out and to try to identify what are our dependency. And typically, the project we are looking at the control level is to be able to have reproducible build, to know where they are built, and to be able to use them when you are on our technical network, when you are on an experienced network, in your CI/CD. And so we believe that knowing where everything is built and having traceability for each binary we will run on the control system at the end is the way to go. And it doesn't mean that we will be immune to security problem, but it means that we can act a lot faster than if we need now. So I don't know if you have other experience in other control system. I would really like to hear about other solutions that you are developing or looking at. Is there anybody that want to speak about that for other accelerators? Feel free to raise your hand. I'm looking at the screen, or if you have complementary question on this subject, anything you'd like to share? I don't see any raised hands. No, nobody? Don't be shy, don't be shy. I'll wait 2 more seconds. So Matt, okay. I don't see any new questions. Okay, so security, we can move on. Let me check what other question we had. There was a question if we are trying to move some of the control system to Kubernetes. So I think Federico reply to this question, because the person asked saying that they were moving the web application part, so their web application were moving to Kubernetes, but the core control system is not. So I think the answer for us is we are still studying. So we have a project looking at Kubernetes. Now it's the same of what you say. We don't have plan to move anything directly related to the control system controlling the electronics, but of course for application around the accelerator, people are very interested in all the container technologies. So there's a project looking after that, and again, same answer as before with Remy. You can have a look to the Kubernetes talk, to the container talk next week, where he will present what's new.
If I may add a comment on that, it's the added value when you're really tied to hardware. I mean, it has to be questioned. When it is about web applications, it makes total sense. Or when you want to really orchestrate your data center, you want to abstract away your generic hardware, I would say, generic computing power, that's okay. But in the context of, let's say, VME or ADCs, beam performance monitor, then it's less obvious.
Checking if someone has his or her hand. I don't see any direct question. No, nobody else. I'm checking because we are many participants, so I need to scroll through screens. Okay. So I don't see any raised hand. Okay, so let me go through the list of questions again. I will have a look. Yeah, there was some comments that the migration from 6 to 7 was finishing, and that we need to look at what the future, what will be possible for the future. So I hope we already reply in the first part of this session to this question. And we don't have a definite answer to what will be next. We are looking at everything, and I think for the server use case, we will have a solution rather soon. For the control system, we are still discussing. So I think we'll need to keep in contact and to try to send you more information when we have everything sorted out. And as you see, for us, it's not easy to decide with everything we know nowadays. So maybe we need to wait a bit more. So we will see how it goes, but I don't have a definite answer to this question. And I think I went through the questions that we can answer. If you have any other question, please do raise your hand, because I ran out of questions from the survey. So any comment, any feeling about what you would like to use, or? No? Okay, so.
Question for the audience.
Okay, go ahead.
So actually it's my curiosity about RISC-V, if someone is really considering it, not right now, but perhaps in the next years.
Any RISC-V takers? No, I'm checking.
RISC-V, but also PowerPC or any other architectures that, well, nowadays are not anymore in fashion, like MIPS or others. So are there other CPU architectures other than ARM and Intel?
So I guess Intel still wins. Okay, thanks. So We were supposed to break in 10 minutes, but I think if you don't have additional question or you don't, another question. So from Johan Forsberg, another question. Have you considered the platform independent packaging such as Conda? Yes. So we have someone that know very well Conda in our team now, and for Python there's a project called ACC-Py that is managed by Phil Elson at CERN and is looking how to package specifically Python. So I don't know if Conda can package more than Python. That would be because I'm not super familiar with. I know Conda in the context of Python, but do you want to comment, John? Or it can. Okay. So you are looking at packaging more than Python with Conda as well. Okay, that's interesting. Now this is not something we looked at as far as I know, but I would
From my
like.
side as well.
Yeah, I can. We've started. Can you hear me?
Yeah, all good.
Yeah, good. At Max 4 in Sweden, we are trying it and using it for some things. But we have successfully packaged some other stuff. It's not really tied to Python.
Okay, very good to know. I didn't know. And what's your experience so far in terms of packaging complexity, different like using CI/CD to publish packages and things like that? Do you look in this area?
We're running our own internal repo, and also there is quite a lot of packages available, so we haven't had to build too much. There's the Conda Forge community repository, which contains many things, and it's fairly easy to upstream your own packages. So it looks good so far.
Excellent. Okay, something to note down. I will have a look as well, because I was not aware that you could package completely everything with Conda.
Well, I cannot say everything, but it's
good to know.
And it's nice not to tie yourself too much to the platform in some sense.
Yeah, it's true. It's
a platform in itself, of course, but.
Yes. So this is as well one of this is a bit of transition to the next talk. This is if you want to become completely independent from the platform. I was investigating NixOS because it has a bit of traction, but it's a bit early to include it in the study for now, because we don't have experience and you need to relearn everything from scratch. So I guess for you it was the same with Conda. You had to because I don't know how you package your things before. Maybe you didn't package anything, so you moved to a new system, or
we went from CentOS and RPMs.
Okay.
We still use that, but
okay. Because for us as well, we would like to, if we do a jump, because we have quite a lot of experience, I think Federico mentioned, with RPMs, because we have basically what Fedora does in the public for EPEL and Fedora, we reproduce at CERN the setup, more or less. So we have a way to do CI/CD for we have automated repo generation from Git source to the final RPM signing and everything at the IT level. So this is something we could reuse in the control, because for the moment we didn't move to it yet, because we are waiting this discussion to mature, basically. But yes, this is everything with the new packaging. You need to learn a new language, and I think this is one of the barriers that we need to be conscious about. I think it's one thing that you need to embark your developers and everything. We never manage. I'm thinking at CERN globally to embark people to build a lot of RPMs. It was really specialist building RPMs because it's maybe not as convenient as it could be. So maybe Conda is a lot better, faster, and things. So this is something that we can look at.
Well, I think it's a plus that you can run it on your own machine, independent of your operating system and so on. So it makes it a bit easier to get started with, maybe. But
correct. Yeah. So the distribution agnostic part, you mean?
Yes. Yeah, it's available for Windows and Mac OS. So.
Yeah. Excellent. That's very interesting. Thanks for sharing. It's really a good point.
Thank you.
Okay, so we still have time for a question because you see, not everybody's shy. So don't hesitate if you have something you would like to share, something you're working in. I see Carlos as this.
Yeah,
Carlos.
I just, can you hear me?
Yes.
Yeah. So just a comment on Conda. We also use it. I think that one advantage over using native packages is that it is also coupled with virtual environments. So essentially, you can update stuff independently, and it's well, we find sometimes that a certain application needs to update libraries, and another one cannot afford to update the libraries yet. So we get blocks in that regard. And with Conda, you can get away from that because each application can live in its own environment. So that is, for me, it is the main advantage of using Conda for controls. Because if you look at the packages themselves, they are, I would say they are not as good in terms of managing dependencies and allowing to package everything and so on as the native packages. So the only reason for going that way, in my opinion, is because you have the extra isolation of having separate environments for each application.
Okay, just a follow-up question. Do you manage your Conda with some config management system, so you can basically recreate them in case you have a problem, or you just use requirement.txt and you create the new environment?
So for the non-Conda packages, we use it. We use Salt.
Okay.
For the Conda environment, we don't. Because of the different context in which we use it. So we just use we just install each thing separately manually, let's say.
Okay.
So for our case, we're only starting to use this for real, but we are using Ansible to build environments for each application, basically.
Oh, we should talk because we have the same requirement in Ansible to build ACCPy to have a way to put all the environment at the same place on the server to be able to back up them in case we want all these kind of things. So yeah, it's a hot topic as well on how to manage development. And one follow-up question, Johan, do you have a dependency management inside your institute, or you just take packages directly from PyPy? You have your own repository, or?
We do both.
Both, okay.
So we're in some kind of transition phase, I guess. We're not sure what we will do. So we build packages. We do a lot of Python stuff. So we do PyPI packages and Conda packages and still build a lot of RPMs because that's what we used to do. So
okay,
we're trying some different things.
Okay, same for us, and we want to have a strategy a bit for the next release, the next distribution we choose, and we are in the middle of trying to define a strategy around that. So yeah, we should stay in touch and have a coffee maybe one day.
Yeah, sure.
Yeah. So that brings us to the break. I think I need a coffee because I spoke too much. So let's break for 15 minutes, and we'll move on to the last presentation and the last section, which is a bit about what could be done in the future. It's not, to be clear, it's not something that we are looking at CERN. It's more to give a new concept around distributions that are a bit newer to the main public. So we will talk about that when we come back in 15 minutes. See you later. Thanks a lot. We will be restarting in 2 minutes. We'll give 1 more minute for the people that have the link in the application, and we can start. Allez, 30 seconds. Okay, so let's go for this session block. So originally, the goal was to have 2 presentations. Unfortunately, from last minute cancellation, we won't have the second one, which is a pity, but I will say a few words about it at the end of my presentation. Just to confirm, you can hear me, you can see the slide? Someone can just tell me it's all good?
Yes, I can see.
Okay, excellent, thanks a lot. So the goal of this presentation is to show you what is going on in the Linux distribution ecosystem, and one distribution that is keep getting a bit of advertisement those days is NixOS. And as I'm really interested in distribution, I have been working on Scientific Linux, on CentOS, and on different projects. I was a heavy user of Debian in the past as well. I'm really interested in what is going on in the different in this landscape. So I decided to show you a bit what is NixOS and what it is about. The presentation will be separated in 4 different parts. The first one will be what is Nix, because Nix itself is a language. I will come back to that in a minute. Then I will explain what is the Nix package manager, which is, as we talk about Conda just in the session before, it's very close to what Conda can do. And then I will move on to NixOS and to try to show you how it works basically. And finally, there will be a discussion on how you can manage a fleet of NixOS. So imagine you have your cloud, you have AWS, Azure, and you want to deploy Nix somewhere. So this part will be a bit less detailed because this is one of the part where I didn't play with the tool myself. So for the rest, I had time to do, because I wanted to do a hands-on tutorial when we were supposed to be a bit less for the training, and I'm still interested to do it. So maybe we can arrange something if people are interested in Nix to do a session where we do hands-on building OS, which is quite fun. but I'll come back to that at the end of the meeting if people are interested to follow up. And so let's go. Nix. So Nix is a lazy programming language for package management. The website explains you how you can install it on any Linux distribution or macOS. So it doesn't support Windows, but it does support Linux and macOS. The installation on the website is a bit more simplified than that because they are doing curl -o and sh the script directly. But as a sysadmin, I hate that. So don't forget to review the script you're downloading before executing it. And basically, when you did that on any Linux distribution, then you have another package manager and you can install packages. I will explain a bit on how everything is packaged just in the next slide, because I think it's nice to see the language first. So it gives you an idea of what is the language. And after we will come back to the repository, to how package lifecycle is managed and everything. So for this, for the purpose of the workshop, I created a small ICALEPCS package, which is a Python Flask application that just return hello to the workshop on the website, basically. And I created a GitLab public link, so you should be able because I think I didn't post the slide. So when I post the slide, you will see that this link is clickable. So if I open it, you will see that my application is here. It has different parts. So it has the famous Nix language description, so package description itself. And after it has the application itself, which is just simple Python code that just create a route and if you call the website, it tells you hello from Shanghai Research Institute. So this is super nice. The goal was just to show you that we can build a reproducible build. So it means that after this presentation, if you decide to try Nix and you run this Nix build on this ICALEPCS package that you can download from GitLab at CERN, you will rebuild exactly the same of what I did. So this is true for now. This is true for the Nix OS that is available today. Because, for example, if the Python version change, then you will build something else. Your package will still be called ICALEPCS 21, but it will have a different hash. So you see at the end, at the end of the slide, when you finish the build, it downloads all the Python and then it will give you a hash. It's a cryptographic hash, and it allows you to identify any package in the Nix store. So we'll come back to that. I wanted to show you how it looks like first. So don't be worried, don't be scared. I will come back to the detail on all that. So Nix, what it is? So it's a purely functional manager. It started in 2003 as an academic thesis, if I remember correctly. And the goal is like you can build package and it will not affect anything else on your system. One more thing is I always use package. In Nix world, they call package derivation as well, which is a bit confusing at the beginning. So don't be scared. The derivation is kind of a package. And at this time, Nix proposed as binary E686, x86-64, and ARM64 architecture. And as I mentioned, you can install Nix as the Nix packages on Linux and macOS. It's focused on reciprocity and portability of the build. So it means that everything you install in your Nix store, you can copy to a new machine and it will work the same. So this is really important point in the Nix philosophy. The goal was to limit the impact of what you could do on a system and to keep a system in a good shape for a long time. So this is only Nix. It uses sandbox to isolate builds. So as we talked with Conda about virtual env, basically Nix is virtual env for any language. This is the same idea. Basically, when you build a package, it will sandbox everything in a simple way, and it will not interact with other parts. And of course, the package management define a lot of different phases. So basically, you can have an unpack phase where you get a tar.gz or a zip file to download from GitHub, and all this thing has been automated by the language. So you don't need to reinvent, I need to download this file. We just put the link to your GitHub release for the project, for example, and then it will download. And each of these phases have been adapted for each language. So you don't need to reinvent the wheel each time you want to package something. You just follow what are the best practice for the language you use. I wanted to say a few words as well about Nix Unfree. So Nix itself allows to package a proprietary application, and the Nix package manager that we'll be talking in a minute provide a way to install, for example, Oracle Instant Client, Virtual Code, Zoom, and everything. But you have to enable it because this is considered as unfree Nix packages if you would like. So I wanted to show you an example in the Nix repo that my example was super simple, but you can do far more advanced thing. So you always have this default Nix to know how to build. And for example, here root is a library that is very well known around physics, and it's already packaged in Nix. So you can see that it's version 6.24. And on top of that, there's some patches that are applied. So all the packages that are published by Nix can be checked on GitHub on how they are built. And again, if you want to build it locally, you will rebuild it exactly the same if you build it with the same dependency, because the important things to understand is the hash, the cryptographic hash that defines the package is compute with all the input library you put for the package. So the combination of all the inputs will make a package reproducible on the long term. One thing is I wanted to mention is Nix Shell. Nix Shell allow you, for example, here I just show you with what it does with the ICALEPCS package. It allow you to enter in the build environment. It allow you to see what you can do, and basically you have access to all the variables that you define. So for example, here in the previous example, I just said that I want to build a Python package. I didn't mention that what version and anything. And here you can basically define, you can click up, sorry, you can just check what are the build inputs that have been selected automatically by Nix. And of course, it means that in the previous example, if I come back here, instead of putting Python free package here, build Python application, I could ask for a specific version, Python 2, Python 3, 3.6, 3.7, everything that is already packaged. So this is one of the important thing of Nix is you can run as many versions of different tools in parallel. There's no limitation like more traditionally on Red Hat, Debian, Ubuntu, where you can not run application in parallel. This is not completely true because there's patch around that for distribution, like on CentOS software collection and things like that. But it's not necessarily something that is directly built in the system. So this is basically the Nix language, the Nix tool you need to use to build a package. Now we'll move to the Nix package manager, because what you're interested in when you want to use Nix is as well to be able to install binary and to use them on your system. So Nix package is a repository which contains definitions for 80,000 packages. I think last time I talked about Nix, we were at 65,000, and now we are around 80,000 packages that are packaged for the Nix distribution. I will show you the search because it's quite impressive. the search interface for Nix. So for example, to give you an example, if you look for OpenGDK, you will see that you have many GDKs that are packaged already, and you have detail on everything you need here. It explains you how you want to install it if you want and everything. And that is all installed in /nix store on your distribution in parallel to your normal OS. Okay, what I said Oracle before, so I think if we should look for Oracle, you will have the instant client, which we use quite a lot at CERN. I don't know in your institute if it's the same. As I mentioned, you have Zoom. So Zoom US is here, so you can install Zoom. You have a lot of different package and Python version. And this is quite interesting, and it allows people as well to choose really what dependencies they want to keep on. Now, let me move back to the presentation. So one interesting thing as well is with the Nix package manager, you can decide that you want to use a specific Git commit from the Nix package GitHub repository. And you can basically stop in time, do a kind of snapshot of what is available to your system. So you can tell, okay, I don't want to get package after because this Git commit is the last one I want. After, I don't want to get the update. So you can configure Nix to do snapshotting at this level. So it's quite interesting for few of our use cases, and we are still looking at how it works, but it's very interesting. And you can configure a lot of alternatives. So alternative is, for example, if you want to build with LLVM or GCC. Imagine that one of your package is built with LLVM, but you want for your system to rebuild it with GCC because you found that you have better optimization or something like that. And Nix, in the language, in the file I showed you before, you can add an overlay that will tell the package that, okay, this package, you don't want to use the one that is in Nix package. You want just to download the source. And instead of rebuilding with LLVM, you will rebuild it with GCC. And after it will be available. Of course, the hash of this package will change and it will be available locally. If you want to contribute it upstream, you will have to go through the process to contribute a Nix package. So this is a bit outside of the scope of this distribution, but I'm happy to talk about it later. But the documentation about how to contribute package is very well done. So I didn't think we need to go in the detail. One other thing that is important is all the artifacts that are used in the Nix package channel repository are cached. So it means that you can always rebuild something that has been put in Nix package. And you can always install a version that has been published once. So that's it about Nix. I wanted just to, I did a kind of Rosetta Stone of the basic of what Nix allow you to do. So I put CentOS, Debian. I hope I'm not too bad in the instruction, because I think all the Debian Ubuntu, because I didn't use Ubuntu in a while, so I hope apt is still the default tool. Otherwise, I will remove Ubuntu from the table. So this is basically it. I put it as a reference, but you will see that it's not very problematic. It's really close to what you can do. You just need to learn new commands, to install package, to remove package. And one nice feature that is not available in other package manager is the rollback option. You can always, when you execute something with Nix, so you do install 10 package, you can always roll back. You can say, oh no, I did a mistake. And as packages don't have direct interaction between each other, you can always roll back. So this is quite a nice feature when you get used to it. And finally, you can list all the packages you have installed as any other system. So before I start with NixOS, I wanted to do a 2-minute break in case we have questions around Nix language, Nix on OS. And I wanted to ask you, did you, if you can raise your hand, if you ever heard about Nix before, just to give me an idea in the participant to see who has heard about Nix before. So 3, 4. Okay. 5. Okay, excellent. 6. Okay, cool. Excellent.
I have
So
a
perfect.
question. Can I?
Yes, go ahead.
So about
Please.
the last thing you said about the rollback feature, but doesn't DNF has this feature, the DNF history rollback?
Yes,
So is it not equivalent?
it's not equivalent because the rollback can fail. I should relook at what exactly, but the problem is it's not atomic. So it really depends on what repo you have configured at the time X. So you can roll back, but depending on what has been updated in the repo, for example, your rollback may fail. And if you don't have as well a repo that keep old version, you can't roll back in DNF. So Nix by default keep all the version. And so you can always roll back to some existing states. So does it reply to your question?
Yes.
Okay, thanks. I'm checking the chat in case. So I don't think this is the question, it's a comment. Okay, there's a talk. Okay, excellent. So I will continue if there's no question. Nobody else has question. Okay, so NixOS. So you can imagine that people looked at Nix and thought, this is really nice, but I don't necessarily want to run Nix on top of Ubuntu, Debian, Fedora. I would prefer to have an OS that is built with the same packages. So this is what NixOS is. So it's a Linux distribution based on the Nix package manager, and it support repository and directive system-wide configuration management and atomic upgrade and rollbacks. So this is taking notes about the previous thing on Nix. With NixOS, you can always go back to a known state. So we'll show you how it looks like when you reboot your server and things like that. And what was the last thing? Everything is built from pure Nix functions. So the language you already learn on how to package, you can use to configure your system. So the investment in learning Nix is quite high at the beginning, but as you will see, you can use it on the NixOS, and after you can use it as well to configure a deployment of your NixOS. So as usual, the learning curve is a bit steep at the beginning, but it has benefit long term. Installation guide. So I put a note on the installation guide. The installation is not very user-friendly yet. You still have to partition your disk manually with one of the tools that proposed, but it's not great. So my approach was a bit, let's evaluate through virtual machine on our OpenStack cloud. It would be very nice if we can have. And there's a super nice project, which is NixOS generator. Let me show you. It gives you basically a wrapper on how to generate image for all the common formats. So I put a list in the thing, but you have, as you can see, you have a lot of default installer that you can use. So for people that like LXC, you could use LXC. You can even use the KExec directly. You can create an installer ISO with your settings. You can create an EC2 image for Amazon. We have VirtualBox as well, which is quite helpful if you are using local development, and VMware. So VMware I didn't test because we don't have VMware anymore here, but I would be very interested. And the one I used for my test was OpenStack. So basically, this is pretty straightforward. You just create the OpenStack image. And as usual, you have a Nix file, default Nix, that define what you want in your image. So here, it's a bit more complicated than the one I show you, but this is the same principle. You can configure everything you want for your OS in this Nix file to build it with NixOS generator. So the NixOS generate will allow you basically to generate an image for most of the clouds that exist or for your local usage. So if I come back here, is there a question? Because I was listening to a mic. Let me just check. how does this compare to OS3? Piotr, can we take about that later, because this is I put that in my last slide. So yes, I will say a few words about that.
Yes, and you have another question about comparison to containers, just about.
Yeah, so Jill, Nix seems to solving a similar problem to container. Can you comment on the comparison? So Nix provide a package manager. So I agree, it's closer to what it's close to what container does, and it join basically the question is for RPM OS 3. Fedora decided to use container to package. I will come back to that a bit later, but because I need my slide. But yes, it's the same problem, but you can install Nix in parallel of everything. You don't need a complex setup to run Nix packages, because this is just a file in the /Nix of your system. And the advantages is reproducibility, because for example, container, if you don't have an infrastructure to detect what version of container you have, how you build your container and everything, it's pretty impossible to track. And one thing we realize as well is if someone asks you to rebuild a container in a year, it's very hard to do, because you can't really know all the dependency. You don't know necessarily how the people build. So if you have a CI/CD, a very structured CI/CD, you can know how the container was built, what time of the OS, and rebuild it exactly the same. But you will always have to keep track of everything. With Nix, you dodge this problem, because you will always have access to what was built. So I don't know if it replies to the question or if you have other comments, Gilles? Gilles? Sorry. No?
Yeah, that's actually quite a good answer. Thank you. I mean, we do use containers, and we do have strict CI/CD, so we do keep track of. We have to keep track of everything. So it's important, I assume, to keep hold of your Nix cache somewhere in order for all this to work. And is that right?
So for your local build, you mean if you create your local channel? Yes. If
well,
you're
saying that you don't have to worry about, you can always reproduce things, but in order to always reproduce things, you would need to make sure you had kept your cache, because
the Nix package
upstream, right? Yeah, okay.
Yeah, the Nix package, the 80,000 packages that are built, all the artifacts are kept. This was my point. But yes, indeed, if you do local builds and you add a different channel because you want to do like another repository like you would do on Debian or Yum, then yes, it's your responsibility to cache your binary. How is it called that? Binary. There's a word in Nix world which I forgot. Binary cache, I think. So yes, it's your responsibility. So it's not magic, and there's some work about it.
And also perhaps when you come to package something that hasn't been packaged before, then you need to do that. Whereas in the containers world, generally speaking, you'll probably find an RPM or a deb or something for most of the things you'd want. So I guess it depends on how easy it is to do that as well, isn't it?
Yeah, it's pretty easy. And as I said, there's 80,000 package done by the community, so it's quite impressive. And I think you can find pretty much everything. When I did my test, I wasn't blocked by packages that were missing, because there's a lot of them. And I think one of the things that is nicer than container for this approach is you can rebuild some package if you need. So it means that here we go basically more on a distribution close to Arch Linux, for example. So you can always retake a package and rebuild it with a specific option you need, which for container, it will be harder. It means that you would need to redo a different tool chain in your containers rather than just overriding one option in the packaging format. So I'm not trying to sell NixOS. Don't get me wrong. I'm not. I'm just presenting to see what are the interesting parts you could do with Nix. But of course, it's kind of the same problem. It's a new thing, so you need to package everything with it, and after you need to understand it, and you need to keep track of what you do. So it won't revolutionize clearly the thing. And
okay,
I think
thanks. That's a good answer. Thank you.
Both of containers and Nix could could work in parallel. One of the things that we were talking before is SDK. One of the good things with Nix, it's possible to basically distribute the SDK and then give a Nix shell to someone, and he can try to build something in this Nix shell with the exact same config as from anywhere else the tool was built. And he can verify that he can rebuild exactly the same thing because the hash will be the same if it is the case. So there's another, I think, dimension that is interesting in this reproducible build that for me, it makes more sense to do it with Nix than with containers. But in terms of how easy it would be to put that in production, I can't comment yet. I don't have enough experience. Is this okay? Do you need?
That's a great answer. Thanks. As it happens, we're using containers to create development environments as well. But again, we're only just trying it out, so we don't. I don't know which is the best way to do it now.
Okay, good. So we should stay in contact and talk again. Yeah. So a few notes. So it's just to show you basically that on NixOS, the current system package are not on /nix store. They are in different current system. It just show basically if you list this file, you will see what package you are running on your OS. And I wanted to show you how you modify basically NixOS, because the NixOS is atomic. So basically, you change the configuration. The configuration, instead of being called default.nix, is called etc nixos configuration.nix. And in there, you can change all the setting of your distribution. So for example, here, if you want to add another package, you will add it after Emacs. If you prefer Vim, you will remove Emacs, put Vim, and just rebuild your NixOS. And this is a command that is used to NixOS rebuild switch. So it means that atomically, it will apply your configuration. So it will be sure that it can be applied, and then you will get a configuration that is working, and it will be switched in the second that is done. So of course, that means that when you change kernel and other things, you have entry in your grub. So it means that each configuration, you can boot back in the previous one. So it means that if you do every night you want to change something, you will get a new entry in grub, and next morning something failed, you can go back to the previous version of the OS. And again, it's atomic, so it's not like you go back to something that is slightly the same as before. It's exactly the same of what you run the day before. So in terms of system administration, I see few advantages of that. Of course, it would have, again, to be tested. I don't recommend anything in this talk. It's just showing you what exists. But yes, to us, it looks quite nice as well. What could be done with such a system? And I wanted to show you a bit more of configuration you can do in your configuration.nix. So you can enable option. You have hundreds of modules that configure different things. So this is one thing that you will realize when you get to the Nix community. People are helpful, but you are overwhelmed with information. Sometimes you don't have enough information in some project. So we were talking, for example, about the documentation around how to build a complicated RPM package. The documentation is quite missing. On Nix, it's the reverse. There's so much information that you can easily get lost. So the best approach is there's a lot of examples from NixOS on the official repository that show you how you should configure. So this is an example from the infrastructure of NixOS. So they explain what package they install, where they mount their partition. So I think it was a nice example to show you. But as you can see, the language is quite, as it's declarative, it's quite easy to understand and quite easy to modify. So yeah, this is what I wanted to show you by that. I wanted to retake basically because this the title of the presentation was reproducible, declarative, and reliable, and I wanted basically to go through that once more with my random notes of what I discovered when I was doing reproducible builds. So what I mentioned before with the SDK is, to me, one of the things I saw that could have value is we could really provide a SDK for anything meaning like not a SDK only for Python, a SDK for C, for C++, Rust, Go. You can with Nix shell provide really easily some way for people to build against something. So for me, that's one of the big advantages that I don't see a lot in other way of doing distribution. And the big thing here as well is it means that you can you don't need to have an XOS to do that. You can do it on your Mac. You can do it on your probably soon on Windows. You can do it on your Ubuntu. You can do it on your CentOS. You decouple completely the SDK from your basically OS. So this is one of the things I noted. And one other thing is there's a big investment in package management for all teams. And if you go to Nix, if you are looking at Nix, you will directly see that if you don't spend time with people to explain them package management, they will be lost. So there's here it's one of the big so the language is complex. In a way, it's good because you can do a lot of things, but at the same time, the investment to the learning curve is super steep, in my opinion. After a few months playing with it. Declarative. What I've put is, yeah, it's a virtual env for everything. So this is the same a bit advantage. It's trivial to build OSIMA. It's trivial to cross-compile as well. You can really, with 2 lines in your Nix config, do cross-compile for the free supported arch, so 32-bit, x64, x86, 64, and R64. So as nobody was really interested by risk, it's not a big deal that it's missing for the moment, but we'll see how it goes. And I have an example of cross-compile, which I won't have time to show you today, but if people are interested in seeing how we could do cross-compile, I'm happy to do something in a bit more limited audience. For reliable, I said, in my view, rollback is very useful. And sometimes you can understand a lot by going back to the old system. So for me, especially for the OS, I see it as a super nice integration with Grub. And we can always go back to the specific OS we were running the day before, and not an approximation of, we said, we did the yum remove of the package, it should be the same. But you never really know if it should be the same, because yum doesn't take care of configuration, doesn't clean up configuration. So yeah, I see it as another advantage in the reliable part, which is what I wanted to say. So maybe we can take a few questions on Nix OS before we start on the rest of the presentation. If someone has a question on the OS itself or something so far. Anybody?
Can you repost that command, that Nix shell command you showed? Am I supposed to be able to download that? -p.
So what is it for -p? I don't remember. It just basically tell you that you want the environment of this package.
Does that package exist? I'm just trying it now, but I'm getting an error. So
no, you need to do the first step of the first slide if you want to build it locally first.
Okay, all right, thank you.
Because sorry, I didn't push the package to because it makes no sense. It's not very useful package. It's not in the main repo. But if you take my GitLab and you just run a Nix build, after you will have locally, and you can test the Nix shell.
Thank you.
Again, if we want to do a hands-on thing one day, I'm really up for it. It's just that with 100 person, it was a bit complicated. But I'm really happy to talk about it around another Zoom one day if you're interested.
Okay, thanks.
So how about GUI apps? Yes, it's working basically. So you can build anything, and Nix, the package manager, manage all your bashrc env to allow you to execute Nix application before the OS application. So it would mean that both are supported as well. You have Wayland and X server. So you can build against, when you build an application, one of the directives you can choose in your Nix language is for which display saver you want to build. So, and after, of course, your your application will have two versions and two different cryptographic hashes that will, one will be for Wayland, the other for X. So this is how it works on the Nix world. You build against Wayland or X server, and after you run the one you want. But you can install both in parallel if you want. So it's quite nice as well. Does it reply to your question, Piotr? Or... Yep.
Yes,
Yeah,
absolutely. Thank you.
Okay, excellent. So two more seconds. Yeah, we have 5 minutes. Okay, so let's move to the last part, which is quick. It won't be 10 minutes. It will likely more 5 minutes. NixOps, I wanted to mention it because this is the NixOS folks that developed from the Nix language a way to deploy your application like Puppet or Ansible would. So it means that you can define with the same language deployment in cloud, in another machine, in VirtualBox, and everything. So if I show you the manual quickly, I wanted to show you the manual. So the manual is quite big. So as here, you can install it first, and after you can define some configuration, and you can say basically where you want your HTTP running and things simply. And from this Nix file, so here it's called trivial.nix, you will basically apply it to a remote host. And NixUp is doing that. So it's applying any Nix configuration to a remote host and allow you to manage SSH keys and all the deployment like you have in Ansible. It automate all the burden of having to access the host and things. So this I didn't play with because as you can see, it's not something we use directly as CERN. It's more like a presentation to show that it exists. So this I don't have a lot of experience, and this is still early in the battle. There's a lot of tool trying to compete to do that. One is Morph, which looks very very good as well, and has far more functionality than NixOps. So the goal is the same, but on top of that, you can, for example, store your config directly in some Git repo and then apply them with tags and things that NixOps don't, at the first glance, support right out of the box. One of the other projects that is super nice is Hydra, sorry. And Hydra is the continuous integration for Nix. So this is what is used to build everything in the Nix package infrastructure. So the famous Nix package I mentioned before. And this tool is used by a few other companies to, and as well as CERN. So the guy from LHCb, the experimental HCB have been building their application with Hydra and as Nix package since 2018, I think. So they were quite early on the train. So I put a link at the end of the presentation with a Nix user at CERN I knew of, and there's a paper that has been published in another conference called CHEP. So if you would like to have a look, don't hesitate. And finally, a project that has been released really recently is Nix GUI, to simplify how you can build package with graphic interface. So it allows you basically to search for what you want to do, and it gives you errors. So this is pretty new, but I thought the idea quite nice. So it will be like the Visual Studio of how you build Nix package. So if at some point you are more serious about adopting Nix, it will be something that could be quite fun to investigate and to play with. So that's it for the tools. So I go back to question, but as we don't have too much time, and guess after 3 hours people want to break as well, I wanted to mention to say few words about basically RPM3, which is what power Fedora Silverblue and Fedora CoreOS now. And this is basically the take of Red Hat on the atomic update business. So I've been running Fedora Silverblue for the past 6 months on my laptop, and it's really similar to what you get with NixOS as an experience of rollback. So basically, you have your grub integration, you have a menu with everything you run, and you can reboot in the previous OS, and everything is atomic, so you never have problem. And Red Hat is building that from a project called RPM-OS3. And RPM-OS3 manage all the OS package. But their approach for user space then, as Piotr know, is to run Flatpak, for example. You can just basically install Flatpak on the user space, and your OS will not be touched, and you have your Flatpak, and you can just run, and your Flatpak will be used. And another approach for which is quite interesting, it's called Toolbox. It's a tool developed, so if you look for Fedora Toolbox, you will find it, that allow you to run a container for running any application you want to work on. So basically, you just type toolbox run something, and it will run your application. And it's super graphical application, which for us is quite interesting. And we are investigating this thing because it can run on CentOS 8. It has limitation, but it will be shipped in CentOS 9 stream. So in the future RHEL, this will be one way of running graphical application in containers. Because for some reason where we want to run containers to run older application or newer application, we have both use case. This tool will allow us to automate all the complexity around exposing your X server or your Wayland and everything. So this is something that we are looking at. And unfortunately, someone was supposed to come to present RPM OS 3 today, but because of the time zone, something didn't play out. So this is why I put that as a bonus. But I hope that if few of you are interested in this business, we can arrange to have a presentation soon in another context. And for me, that's it. As I mentioned, I put few reference of people doing Nix in high energy physics, and the talk about LHCb experiment they did a few years ago, in 2019, I think. Yeah. So for me, that's it. We are on time. So is there any question right away? Was it helpful to have this Nix introduction? It's not very in deep, but it was just to give you a thought about Nix and to give you ideas on what can be done. Any raised hand? I'm checking. No. Nothing. So, Stefan, a question. Do you intend to use Nix at SEA in the future? Are there any of you willing to use it? So, no, we don't have plan yet because it's quite new. So this talk was really, as you see, it doesn't have the CERN logo or anything because it's on purpose, because we don't want to say that we will use it or not. As every company, we are looking what is done in the future, and we have personal laptops. So I know a few people that are interested in Nix in their world at CERN and in experiment, as you can see on this link. The presentation is quite intense and very nice. The paper is really interesting. So I can't speak for the whole CERN. What I say for the accelerator sector at this time, no, we have no plan. So if people contact us about other use case, we can certainly discuss, and we always like to share our experience, but it's not something that you will see in the control right away. And you see, it's already hard to talk with vendors about CentOS Stream or Rocky Linux. Imagine asking them about Nix. So we are still far from this level, I think, which is but it's not a no for forever. It's if people are more and more interested in Nix, Nix is showing up a lot more in the discussion in every channel around the world, in article on Hacker News and things like that. So I have hope that we can talk again about Nix soon. Does it reply to your question? Thank you. Okay. So if there's no other question, I wanted to go to the wrap up. There's one maybe. Wait. No, it was no, it was an answer. So is there? That's a very good question. Is there any curation of packages? So at this time, I would say from the community, yes. From a vendor, as you would have curation at the Red Hat level, for example, no. So this is really delegated to the community, and the community is really picky on what they accept. But it's not a full curation. I couldn't bet my life on the curation of what is in Nix package over the 80,000 packages. Okay, so let's move to the wrap up, because I have an important subject I'd like to speak with all of you before you leave. So wrap up, let's go. I had just one slide, so it's not it's easy. So thanks. So we had 110 participants that joined, so which is good for free online event before a conference. We got more than 50% of the how do you say, subscribed participants, so it's not too bad. Thanks for your time. It was very nice to have you. I hope you learned something. I hope it was helpful that the 3 different track cover what you expected, because for us it was a bit the first time we organized a workshop. For me, it was my first ICALEPS as well. Now, it is my first ICALEPS because it's not finished. So I really like to have feedback. If you don't want to do it right now, feel free to contact me, ask me, tell me what I did wrong, what I did well, and we'll try to improve it for next time. And how do we keep in touch? This is my question to you. I have mailing links with all of you. So I would really like to know if people would like to exchange more, and if so, can we create a mailing list? Do you prefer to have a Slack channel? Do you prefer to have a Mattermost somewhere that everybody can join? Is it of your interest to continue to discuss about Linux distribution, or is it something that you are not interested to discuss every 3 months? So I don't know if you have any feedback you'd like to give me around that. If you would like to keep in touch and you think you like talk about the control are interesting, talk about a bit of what could be done in the future are interesting, and we could do it once in a quarter or something like that. I'll be very interested to create a community around that, because when we started to do all this review of Linux, we didn't have direct contact to exchange with. So really, if you are interested, let me know. You can speak now if you want, if you're interested. If you have ideas on how we can keep in touch, please feel free to speak now. Or if you have other ideas, send me a message later on. Okay, so Joan says that it will be interesting because everybody is at a crossroad. So yes, taken in account. Gianluca, you raised your hand?
Yes, do you hear me?
Yes.
Okay. No, I am not one that is directly working on these things, but at ESO we have a strong interest in both these things, so the Linux distributions, but also we have a group of people that is looking into Nix and that is pushing Nix, even though they don't have enough time to really come out with the things. So having a community that discuss these issues, both areas are very interesting, would be for us very good. And I would for sure put the people that is looking into these things inside this community to discuss with whoever else is interested.
Okay, well noted. So
maybe to have a kind of or a Slack channel, or to have some kind of web forum where a community could could grow around that. And as I say, both these areas are interesting for me.
Okay, okay. So I will check. I will come up. I will try to come up with a solution. Maybe we'll start with a mailing list just to keep who is interested, and after we can move to a different media, because mailing lists are not very interactive. I completely agree. So maybe we could just keep in touch with people interested in a mailing list, and after we can move to a channel somewhere to discuss, to chat a bit more often, and to find people that want to present their project as well. Because this is the thing for this workshop I miss a bit is a bit more content from different labs. So if we can do even a smaller presentation, like we don't need to go for big slots, we can do lightning talks once in a while to present quickly project. For us, it would be really interesting because I really like to build a community around the accelerator labs. I think we are missing that. At least it was my feeling when I arrived in the BIMS department here.
Yeah, maybe to have, I don't know, some kind of event every quarter where one can see how the things are evolving. For example, which Linux distribution is being picked up by the different people with the story of CentOS and so on. That might be a good idea to have a community that meets once a quarter for a short event with the new status of things. I think that would be very useful.
Okay, okay. So let me try to figure out, and I will send the last email to all participants to asking them to join the mailing list if they want, because I don't want to use the same because it's not fair. So I will just do an opt-in email, and people interested can just subscribe, and we will take it from there. Okay, looks like people agree in the chat. Excellent. Okay, so thanks a lot. Any other last question, or we can wrap up? Yep. Okay. So thanks a lot. It was very entertaining, and let's try to keep in touch and have a nice evening. Bye-bye.
Bye.